Hello, and welcome to the 7th grade geometry unit. For students in compacted math, this is topic 10A. And for students in math 7, this is topic 8. In lesson 1, we'll learn how to solve problems involving scale drawings. First, let's connect this new knowledge to previous topics. In lesson 1, we'll use our work from topic 3A and topic 2 to solve problems using proportional thinking. In that topic, we set up and solved proportions and equations to solve problems. Later, we used the same equation to solve various percent problems. A reminder to take notes while you... First, let's understand what a scale drawing is. A scale drawing is a drawing of an object where the lengths in the drawing are proportional to the lengths in the actual object. In the example you see here, as we move from the triangle on the left to the triangle on the right, you'll notice that each side length has been multiplied by 1/2. We want to talk about this relationship using multiplication instead of division. You'll also notice how the angle measures have remained the same size, but the side lengths have been changed using that same ratio of 1 to 2. There are two types of scale drawings. One is called an enlargement. An enlargement is a scale drawing where the drawing is larger than the real object. We see enlargements a lot in chemistry and biology. To talk about the nucleus of an atom, the number of electrons, and the formation of molecules, an enlargement is needed. Due to the size of a cell and its organelles, we need a larger image to see these little organs. If you've ever looked through a microscope and drawn what you see, you've drawn an enlargement. The second kind of scale drawing is called a reduction, and reductions are the opposite of enlargements. Reductions are scale drawings where the drawing is smaller than the real object. All maps are reductions. A blueprint of a house is needed to plan the foundation, the shapes and sizes of the rooms, and plumbing and electrical work. When we study astronomy, we need reduced pictures of planets and solar systems. Compacted students can learn more about enlargements and reductions on the coordinate grid in topic 11. Math 7 students will learn about enlargements and reductions on the coordinate grid when they study dilations in 8th grade. At the beginning of the video, I said you would use proportions and equations to solve problems using scale drawings. Now we're going to connect that prior knowledge with this new knowledge. Another quick reminder that you should be taking notes while you watch the video, and you can always pause and rewind the video if something moves too fast or you feel like you didn't catch something. When we've used proportions to solve problems, we've seen and used a template like this, where we compare the part to the whole. When we're solving scale drawing problems, we set up a similar template where the dimension from the drawing is compared to that dimension in the real image. So it's drawing over real. The left side of the proportion is usually the scale ratio. On a map, if it said that 1 inch is equal to 20 miles, the ratio on the left would read 1 inch over 20 miles. The variable is usually on the right side of the proportion. So if you're asked to find the dimension in the scale drawing, the variable would be in the numerator where it says drawing. If you were asked to find the dimension in the real object, the variable would be in the denominator. In this question, we're asked to find the area of a square window. Next to the drawing, we see that the scale is 1 inch to 2 meters, and the width of the drawing is labeled as 75 hundredths inches. So the first thing we do is we set up the proportion. The scale is 1 inch to 2 meters, and so that's our first ratio, 1 inch over 2 meters. And the width in the drawing is 75 hundredths of an inch, and so that's placed in the numerator of the second ratio. Notice how the numerator has the same label, so inches is on the top because that comes from the scale drawing. And we're asked to find the actual length, so that's why the x is in the denominator across from where it says 2 meters. Now, we're going to look for relationships in the proportion, and we're going to look vertically and horizontally. So first, when I look vertically, I notice that there's a relationship of times 2 in the first ratio. This tells me what I'll have to do to find the value of x. Horizontally, I also notice that 1 times 75 hundredths is 75 hundredths. So that means I can do 2 times 75 hundredths to get the missing value. Both of these relationships tell me that the missing dimension, or the height of the window, is 1.5 meters. The area of the window is the product of 2 meters times 1.5 meters, for 3 square meters. Earlier, I noticed that there was a relationship of times 2, but I could also say that there's a relationship of multiplying by 1/2. Remember that when we draw the scale drawing, we're going from the real image to the drawing. So if I multiply 2 meters times 1/2, I get the 1 inch for my scale drawing. If we multiply the real dimension by 1/2, we get the dimension in the drawing. This is called the scale factor. We can find the scale factor by dividing the values in the scale. So if we divide 1 by 2, we get the value of 1/2, and 1/2 is what's called the scale factor. In this example, the scale factor was a fraction, and so that means that this drawing is a reduction. So reductions have scale factors less than 1. What do you think will be true of scale factors in an enlargement? You got it. So enlargements will have a scale factor greater than 1. We use the scale factor when we write equations rather than proportions to solve scale drawing problems. Remember, you should be taking notes and writing down the important information. These equations should seem familiar to you. They have the same basic structure. In topic 3a, we talked about a constant of proportionality. In topic 4, we multiplied the percent times the original price to get the tax or the discount. And in topic 7a, we multiplied the slope times the x value to get our y values. When we solve problems involving scale drawings, we use a similar template. Y is equal to the scale factor times x. The scale factor is just like the constant of proportionality or the slope. It's the number that you need to multiply the original dimension by to get the new value. In this case, remember the original value is 2 meters. So if we continue with that line of thinking, y is equal to the scale factor times x. X is the real dimension, and y is the dimension or the length of that dimension in the drawing. So in our problem, the length of the window in the drawing is 75 hundredths of an inch, so that goes underneath where it says drawing dimension. We know that the scale factor is 1/2, and we need to find the real dimension, so that's still our variable. Next, what we do is we solve a very simple equation by dividing by 1/2 on both sides, and we find that the real dimension is 1.5 meters. At this point, most of you are probably thinking that using the proportion was a lot easier than using the equation in this problem. And you'd be right. But understanding and using the equation method will be the preferred method in Algebra 1 due to its connection to all the other equation templates about constants of proportionality and slope. So here are your next steps. The notes that you took during this video will likely be enough to fully understand the content and complete the Math Excel for this lesson. Your teacher is still going to unlock the examples and the triads for this lesson. You might not need the examples and the triads, and that's okay. You can skip them for this lesson if you fully understand the content from the video. If you want to do the examples and the triads just to be sure you understand, do that, and do whatever works for you. The Math Excel for this lesson is still required. Now you're going to go back to the Google document and watch the video for lesson 2.